Hello, good morning, good afternoon, good evening, wherever you may be in the world when you're watching this. So this is really a carry-on video from one I did a short while ago where I did a micro-segmentation, or rather I was looking at micro-segmentation using a mix of VRFs and VDOMs. All right, so just to cast your mind back, if you did watch that video, and or for context, even if you didn't, so what I had is I had a root VDOM with some VRFs, micro-segmenting two business entities, and then those root VDOM went to a WAN VDOM via inter-VDOM links, and then that WAN VDOM had access to the outside world. Now, between the spoke and the hub, we're running an IPsec tunnel, and that IPsec tunnel terminated in the WAN VDOM. We're using VPN-v4 segmentation. The various VRF traffic is kept unique over that IPsec tunnel using route descriptors as you would in MPLS. So corp traffic gets placed in the corp VRF on this side, and the accounts traffic from this side gets placed into the accounts VRF on this side. All right. So this side hasn't actually changed, and then what I had is I had a root VDOM where these two entities could then access shared resources, so shared corporate resources within the root VDOM. So for the purposes of the demo, I'm using loopback addresses to emulate actual networks, and here from the data center side, I'm using these again loopbacks to inject traffic from the data center back to the spoke side. Now, where this differs from the original one is that here I'm using a single VDOM on this side. So I've still got the micro-segmentation using the VRFs, but instead of using a WAN VDOM, I'm going to use a third VRF to emulate that WAN VDOM. I'm still going to use inter-VDOM links to interconnect them, so I'm still going to create a hub and spoke routing type environment, but all within a single box, but without using a VDOM. One of the reasons you may not wish to use a VDOM is, one, you want to keep it simple, you want to keep everything in the same root VDOM, and also from a cost perspective. So obviously VDOMs consume a license on FortiManager, so that may be one of your rationale. So if we just look at the spoke logic here, so what I've done here now, still got the two VDOMs, so VDOM 10 is corp, VDOM 20 is accounts. My IPsec tunnel comes into the root VDOM. It doesn't need to be in either one of these because the BGP makes sure that the route descriptors pop that traffic out into the correct VRFs. And then I've got a third VRF here, which is acting as the WAN VRF. Each one of these VRFs has got a static route. So there's no longest match coming, let me repeat that. If there is no longest match coming from the data center, clearly then it says, well, where do I go for anything that doesn't belong from the data center? So it's going to use the default route. It's going to come up to VRF 30. And there in VRF 30, I've got my multiple internet-facing internets, two for various SSEs. If you've got two links to different SSE providers, FortiSASE, for example, and a direct internet access as a gateway of last resort. Now, because these are statics, they're always going to be in the routing table ahead of any dynamics, but I'm also injecting a default originate from the data center. So if all three of these links fail, what will happen is that this static route will float out of the table. It'll no longer be valid, and this BGP default origination will float into the table. So how do we do that? We use a feature called link monitor. And what link monitor, as the name suggests, it monitors an external IP address. All right. If that IP address is healthy, then the default route will stay in this default. The static will stay in the routing table. If that fails, then that static route will disappear and the BGP default originate will float in. So let's have a look at this. Let's start off with the spoke side. Alright, so if I do a show system link monitor, so there you go, I've got one for each VRF. Alright, so you set your source interface, that's in this case it is the inter-VDOM link side that's within that VRF, my server, my gateway IP, which is the other side of that inter-VDOM link, right? Remember, because this is a /30, it's a point-to-point. And then I do, well, what is the route that I'm tracking? It's the default route, all right? And my heartbeat interval, so every 2 seconds check. And the same thing here, the only difference is my next hop is different because obviously it's got a different point to point, right? If I do a show router BGP, okay, so this is my neighbor, which is the other side of the IPsec tunnel. So this is the data center, and then these are the subnets from the VRFs that I'm publishing up to the data center. And further down here, I've got my VRFs, right? So this is keeping the VRF traffic unique. But how do I tag that traffic? So if I do a show VPN IPsec phase 1 dash interface, so here's my IPsec, and it's this little keyword here, set encapsulation VPN ID IP. This basically does the exact same job as MPLS LDP would do in terms of carrying those route descriptors and the route targets and keeping the traffic unique amongst the VRFs. All right. So if I come to this side and I do exactly the same thing, show router BGP, I have got, wrong VRF. Let me just close that and come to the WAN side where my BGP is running. Show router BGP. Okay, so here again, all right, because remember that my IPsec tunnel is terminating into the WAN VDOM in the data center. And so that's where this is coming along. And then I've got point-to-point links from the WAN VDOM pointing into the root VDOM. So we can see that if I come to my global, which is where we configure that VDOM interfaces. If I come down here, here's my one for my accounts. So there's the /30, and here is for the corporate, right? And if we hover over that, we can see the IP addresses. We can also see that Corp 1 is in VRF 10 there, and that is in VRF 20. All right, so that's WAN VDOM side, that is root VDOM side. If we come along to the root VDOM and we look at the BGP here, show router BGP, one thing to notice is that here I'm using eBGP. Okay, so if I look at this, you can see that here my AS is 65001, but my peers in the WAN VDOM are 6500. So if I just come back to my diagrams here, this diagram, so I'm using iBGP between the spokes and the data center, but I'm using eBGP between these VDOMs. Why? Just to make my life easier, really. If I use eBGP, I don't have to worry about things like next hop self. eBGP always exchanges all routes with its peers. Even routes it's learned from upstream devices will also be published to its peer, whereas with iBGP, only directly connected routes are sent across. So hopefully you already knew that. If not, time to study up on your BGP. So if I do a get router info routing table all, what I can see here in the root VDOM, remember I'm running no VRFs here because this is my shared VDOM space. This is where I want my two remote entities, segmented entities, to be able to share common data in the data center. All right, so 16111 is coming from the corporate VRF on the spoke side, and 17111 is coming from the accounts side. Now, from the root BGP, I'm publishing these 16.10.11 and 17.10.11, which are the loopbacks on this side. So if I come well, firstly, let's go to the WAN VDOM. If I do a get router info routing table all, what I can see here is that in my VRFs, all right, I've got, here we go, 1710 and 1610 being published into both of those VRFs, which is correct because they are shared. I want both VRFs to be able to see that. But now the WAN VRF, as the WAN VDOM here, has got a IBGP relationship with the spoke. So if I do a get router info routing table all, if I look here, so here I'm on the spoke side, and lo and behold, there are my routes being published down here. Okay, so if I do a execute ping dash options source 16.1.1.1, which is the corp loopback, and I want to do execute ping 17.10.1.1, that's in the data center, that's the one subnet, and 16 is the other one, and you can see that I can get there. All right, if I change that source to 17, I can still ping, and still ping, right? So both VRFs and the remote side can ping their resources up in the data center, but they clearly can't get to each other because they are segmented via the VRFs. Now, let's just look at that routing table one more time. So you'll see here that obviously I've got those longest matches being learned via BGP, but I've also got the static route here pointing to that third VRF, this one here, VRF 30. Okay, and within VRF 30, I've got all these static routes pointing to the outside world. Okay, I've also got routes pointing back to the subnets in the various VRFs, because clearly if I send traffic from a VRF to VRF 10 or 20 to VRF 30, it needs to be able to get back there, all right? Otherwise, we'll end up with a black hole. So just treat these VRFs as the same way as you would routers. Now, one of the things you'll notice, again, if I do a show router BGP, I'm not using any route maps here. I'm not using any route leaking between these VRFs. I am treating these purely like routers. Routers as a hub and spoke routing environment. So what's happening here now, if I do the show system link monitor, just to refresh your memory, is that these VRFs are using that default route to go across their point-to-point link into VRF 30 and send traffic out, an ICMP ping out to 4.2.2. So if I do a diagnose system link monitor status, we can see here that for both of them I've gotten a live statement. Okay, so let's see what happens. So firstly, let's ping. So let's do an execute ping dash options view. Okay, so my source there is 17.1.1.1, so let's do an execute ping 8.8.8.8, and you can see that can get to the outside world. Execute ping options source 16.1.1.1, and I can still ping to the outside world. Okay, now if I come along to my SD-WAN side here, what I've done is I've put those internet links, the two SSE links, as well as the direct to internet access link, into their various SSE SD-WAN zones. I've got my performance SLAs here. I don't know why those two are down. Clearly they're not down. Why is that showing as down? Okay, I think it's just a temporary hiccup. Anyway, carry on. So what's going to happen here with the SD-WAN is the traffic is going to come in, and the first rule it's going to hit is to SSE. All right, and SSE is saying, okay, that's alive and well, so it's going to choose the selected route. In fact, it's chosen SSE2 there because it's saying SSE1 is down. Maybe I've made it down here. That's enabled. That's enabled. No. All right. If you know anything about me, you'll know that my things are not meant to be tailored. I'm just going to change this. I'm going to change this. And what I'm going to do here is I am going to do Google, and I'm going to do 8.8.8.8.8.8, all SD-WAN members, ping, pro mode, Google, must be an IP, 8.8.8.8. Okay, and we're going to put something like that, 50, and what we'll do is we'll check it every 2 seconds, 2 and 2, and we will say okay like that. And then what we'll do here is I'll come to my SD-WAN rules here, and I'm going to change that to the Google. And I'm going to change this one to Google as well. Oh, that one doesn't, it's only got a single link, so I'm not actually using that there. Okay, that's all up and running. I'm not sure what's wrong with that one, but these are all up and running. Okay, and you'll see, look, it's now swung back over to SSE1 because that is the top of the list within the zone. So if I look there, SSE1 is the top of the list, SSE2 is at the bottom, so it's the preferred one. Okay, that's a bit of a deviation. Anyway, you got a bit of a lesson in SD-WAN there. So if I do that, execute ping, all right, I can ping that. And what I'm going to do here is I'm going to kill one of those SSE links, disable. Now it's using the second one. Okay, and we can verify that. SD-WAN rules, SSE2 now, so let's kill SSE2. Disable. And now it's using the gateway of last resort, which is the direct internet link. So if we come back here, SD-WAN rules, both of those are down because I shut them down, as you saw. So now it's using this. All right, so there's my 3 levels of resilience just in that VDOM alone. What I'm going to do is I'm going to bring up these 2 again. Okay, now what we're going to do is remember that the link monitor, so just to refresh your memory, show system link monitor, is looking for 4.2.2.2. So what happens if I block traffic to that? Now before I enable that policy, I want to again get router info, routing table all, just to refresh your memory, that at the moment I've got all those static routes going out, all right, but here, so because those are live, I've got the static in both these VRFs pointing to their next hop of the inter-VDOM link. Okay, so what we're going to do now is I'm going to enable this policy, which is going to block traffic to 4.2.2.2. So diagnose system link monitor status. Okay, you can see they're dead and dead. All right, so now let's go back. And now my default originate from the BGP perspective has now floated into the table. All right, you can see that. So now when I ping 8.8.8.8, now I'm going all the way across the IPsec out to the data center, and I'm popping out on that side. So hopefully that was clear in terms of being able to give multiple levels of resilience. I'm just going to set that to disabled again to bring those back up. But again, one of the other things I want to show you here is that I'm not using any route maps whatsoever. So let me just minimize that. So here I'm on the spoke device. I have going to come across here, routing objects, no route maps, no prefix lists. I come along to the hub here, routing options in the root, nothing there, and in the WAN, nothing there. Okay, I'm just treating these as I would if they were routers. I'm not trying to import or export routes. I'm not doing any route leaking between VRFs. I am treating these VRFs as though they were routers, just to keep things simple. Now, that doesn't mean you can't do route leaking. If you wish to do it, then by all means you can. But my purpose of this video was to show you how to do this in as simple way as possible, because my belief is if you keep things simple, it's easier to manage moving forward, it's easier to troubleshoot, and when the next new guy comes on, when you leave the company and some new guy has to pick up the bag in terms of managing this, that person can then quickly come up to speed with what's going on, because hopefully it should be pretty straightforward, because literally you're treating these as though they were independent routers, the same way as you would in a good old-fashioned network if you were dealing with physical routers. So hopefully that made sense. Hopefully you took something positive away from this, and yeah, by all means, wait for my next video. If you subscribe to my YouTube channel, you'll be automatically notified when I upload a new one. Thank you very much for your time. Bye-bye.